In this video, we're going to be discussing solving one-step equations using multiplication and division. Now, if you're following these videos in order, we just talked about solving one-step equations using addition and subtraction. And it probably would be good to go back and review that one real quick before you do this. Anyway, with that said, we're going to be using the properties of equality, just like we did in the previous video, in order to solve one-step equations. Except this time, instead of using addition and subtraction, we're going to be using multiplication and division. So what will that look like? Well, I could have an example problem, something like this. 5x equals 30. And that means I'm taking 5 and multiplying it by some number. I don't know what it is, it's just x, and it equals 30. Well, like some of those problems that we did in the last video, if you just look at it, some of these one-step equations, you can probably figure them out. And in this case, what times 5 makes 30? Well, if you know your times tables, x should equal 6. But we're not going to solve equations that way, obviously. We're going to use a process, and the steps that we're going to take are called the properties of equality. So the idea is to get this variable by itself, because by doing so, we're going to say x equals, and then that value will be on the other side, and that'll be the solution. So in this case, 5 is being multiplied by x. So we need to do the opposite of multiplication, which is division, and divide both sides by something in order to get the x by itself. Well, the x is multiplied by 5, so I'm going to divide both sides by 5. And in doing so, these 5's over here cancel, which leaves x all by itself, and then 30 divided by 5 is 6. Sure enough, the answer we thought it was going to be just by looking at it is actually the answer. And we used just now the division property of equality, which says if you divide something on one side, you also divide it on the other side, and your equation stays true. Okay, so let's look at another example with that same kind of idea. This time I have a negative 4b equals 16. So actually that kind of looks like the same, doesn't it? The 6 and the b. That is a negative 4b equals 16. Okay, so again we have this b, which we wanted to get it by itself, but right now it's being multiplied by negative 4. So if it's being multiplied, what's the opposite of multiply? Well, division. So we're going to use the division property of equality, and we're going to divide both sides by something. And what are we going to divide both sides by? Well, that negative 4, because it's whatever's with that b. So when you divide by negative 4, the negatives cancel, the 4's cancel, which is beautiful, so the b is all by itself, and now we just need to worry about what's 16 divided by negative 4? Well, negative 4. You actually get the same thing. Okay, so our value is b equals negative 4. So always what you want to do is you want to go ahead and plug these values back in and just verify that indeed it's true. So we started with negative 4b equals 16. So let's go ahead and put our negative 4 in for b. And negative 4 times negative 4 is 16. Oh, 16 equals 16. That's good. Check. It works out. Okay, likewise, we have the counterpart of the division property of equality, something called the multiplication property of equality. So let's look at an example. What if I have x divided by 3 equals 7? So right now, our variable x is being divided by 3, and when we do that, we get 7. Again, we can probably look at it and figure out that, hey, yeah, I know if I put 21 in here, 21 divided by 3 is 7. Again, that's because you know your multiplication tables. But again, these problems are going to get much harder that you can't just look at it and figure out all the time. You're going to have to do these properties of equality in order to solve these equations. So x is being divided by 3. So what's the opposite of division? Well, multiplication. So we want to multiply both sides by 3. And in doing so, we're going to undo this division that's going on over here, because 3 times this business, really it's 3 over 1. So my 3's cancel, left with 1's all over the place. So it's just x now is by itself, and 7 times 3 is 21. So indeed, we got the value we thought we would get. Okay, let's do a fourth example. If I have something like d over 4 equals negative 1, what am I going to have to do? Well, right now in this equation, d is being divided by 4, and when I did that, I got a negative 1. So, like we did previously, the opposite of division is multiplication. So I'm going to multiply by this 4 that's down here on the side with the d in order to get rid of it. So I'm going to multiply both sides by 4, and on this side over here it's like over 1. That way we can deal with the fractions. The 4's cancel. I'm left with 1's all over the place again. D is by itself. Negative 1 times 4 is negative 4. So that's my answer. And this time let's go ahead and check it again. So I started out with d over 4 equals negative 1. So now let's put my negative 4 in for d. And negative 4 divided by 4. Oh, hey. Negative 1 equals negative 1. Check. It's cool. Works out. Okay, let's keep going and do something a bit harder now. Let's do one with fractions, because I know that everybody loves fractions. Let's say something like 2/3 times y equals 6. So what I'm doing here, I'm multiplying y by 2/3, and then I get 6. So what is y? Well, I don't know. I'm multiplying some number by 2/3 and getting 6. And this one you probably can't do in your head just by looking at it and figuring it out. I mean, you could start guessing some numbers, and maybe you'll get it. Maybe you won't. Who knows? But anyway, so we have this 2/3 times this variable y. Well, previously what did we do? When we had something multiplied by y, we divided both sides by that, right? So let's go ahead and do that. Let's divide both sides by 2/3. And you're thinking, oh, division by fractions, huh? That doesn't sound awesome. Well, it kind of is. It'll work out really nice, I think. So what does that left side look like? Well, the 2/3 and the 2/3 cancel, because 2/3 divided by 2/3 is 1. It all just goes away. So we have our y over there on the left side. Well, what is that right side going to look like? Because we've got 6 divided by 2/3. Let's kind of rewrite this a little bit. Let's actually say 6 divided by 2/3. And this might be easier for some of you. Maybe you like it the other way, I don't know. So really this is 6 over 1 though, so we have fractions. And how is it that you divide fractions? Well, you copy dot flip. So we're going to copy the first fraction. We're going to put a dot for multiplication. And you're going to flip that second fraction over. Really, you're going to multiply by the reciprocal is what you're doing, but the copy dot flip is kind of a fun little thing so you can remember what you're doing. So now what is 6 over 1 times 3 over 2? Well, some of this stuff will cancel. We'll get a 1 there and a 3 there. And actually just 1's in the denominator make that nice. So y equals 9. This one we're definitely going to want to plug back in to verify yes, it's right, or no, it's not right. So I started with 2/3 times y equals 6. So let's do 2/3 times 9 equals 6. Well, again, we'll have 2/3 times 9 over 1 equals 6. And the 3 here can kind of cancel up there with that guy. Oh, 2 times 3 equals 6. 6 equals 6. We're good to go. So even though there are fractions in some of these, don't let that scare you away. What is it that we did? Well, 2/3 was being multiplied by y, so instead we just divided both sides by 2/3. The opposite of multiplication is division. And it's always nice on the left side, the one with the variable, because you know all that stuff's going to cancel out, because we did exactly what we needed to do to cancel it out. On the right side, sometimes that'll be a little uglier, but it's just fractions. Just do baby steps, do your division, multiply by the reciprocal, work it out, simplify the fraction. Sometimes it'll come out really nice, like this one did with just 9. So this is the division and multiplication properties of equality in order to solve one-step equations.